Let's also examine a couple other videos here.
One Direction.
Oh yeah, that's a real one. I don't know if anybody's seen this before.
What is it? Me llamo Juan Manuel Chávez, más conocido como Eddie, tengo 19 años y toco el cielo. Este cielo está hecho de una lata de aceite, de la madera, tirada en la basura, y las clavijas de ese cielo está hecho de una vieja cuchara, la madera, golpear la carne en la basura para hacer las clavijas, y suena así.
Para que te entiendan. De hecho, un violín cuesta más que tu casa.
En ese grupo acá mismo encontramos el colado de violín. Y ese empezamos con el radicado.
La familia que acá vive recicla todo lo que hay en la basura y se vende.
No pensaba antes que yo voy a hacer esa instrumento y me siento feliz cuando estoy viendo a un niño que está tocando un violín muy reciclado.
Cuando ya escucho el sonido del violín siento como mariposa en el estómago, así una sensación, no sé cómo voy a explicar.
La orquesta de instrumentos reciclados es una orquesta que toca instrumentos hechos con la basura.
Y mi vida sería, si la música sería texto de...
La gente se da cuenta que no tenemos que tirar la basura muy fácilmente. No tenemos que desechar a las personas muy fácilmente.
Interesting. All right. Got this as a wedding gift. At the time my wife and I got it, it was like, thanks. But now we put this out on our back porch when the wind blows. make something like that? Very easy.
If they just bought the materials.
Okay. Are these pipes just at random ways?
No.
Mm.
So you would get different sounds.
Anybody had any music theory?
Yes.
Yeah. How many pipes?
5.
Five. It's interesting how they're attached. There's an actual rod through there, and they somehow have a string tied to it. It's very soothing, isn't it? Anybody want to see this? It's awful heavy. I was taking this from my house, and my wife was like, "Is that broken?" I'm like, no. Am I going to get it back? I said, yeah. It is kind of heavy. Is there some mathematics behind the length of those pipes? Yes. Yeah. Oh, no, you'll get your free stuff.
I'm curious.
That's good. I haven't tried this yet. Remember this? But do they blend together? Is there one of those tubes that's the same pitch as this one?
Yeah.
Yes.
Close. But do they sound good together?
Yeah.
Yeah. I didn't even try that before class. There's something that when they built this and they built that, they had something in common. They had something in common. Anybody else want to see that? Anybody ever do any sound editing on a computer? A little bit? Hey, why'd you say that? I use a very simple program. Looks like it's red. Looks like I clicked too many times. I used it this morning. Oh. Best laid plans in place. I just tried this morning. I guess I'll have to restart. I'm totally serious. I tried this program this morning. Oh, look how many times I got that open. We have forced restart. Jake,
I didn't drive, so. Not me. No, I didn't go.
who's got the little red one? Who's got the big red one? Hit the little red one. Hit it.
Did it. Sounds like that's the Kevin.
It's not where they're supposed to sound like.
Mine's higher.
Yours is higher.
Yes, it's an octave.
Oh,
Maybe you have to go.
it's an octave. It's an octave. What's an octave? A to A? C to C? What's an octave? Is there a relationship
Yes.
between the length of this one and the length of this one?
Like half as long.
Half as long.
Yeah.
I actually measured it.
It is.
It's a little bit smaller than half. Now remember this idea between theory and practice. Somebody mentioned something about the wind chimes, right? It's a big long metal tube. And somebody mentioned something about the thickness. Does the thickness of the tube affect the sound that comes out of it?
Yes.
Does the length of the tube?
Yes.
Yeah. Have you ever heard like the phrase fine tuning? Yeah. You've got theory, then you have practice. Who plays guitar? Right. E-A-D-G-B-E. The strings, right? What's the relationship between the top string and the bottom string? Same note, but, yeah, so what makes two notes have the same note?
So it's like,
Oh,
the top of the is the same as the top of the. So it's like
oh, okay.
it's a wave.
It's a wave. It's a wave. Let's see. Thank you, Mr. Irvin. Everybody remembers Mr. Irvin, right? How many days?
26 days.
26 days, ladies.
No, I
Quiet, please. The recording light is on.
Oh my.
Somebody want to see this?
I do.
So this is a program. Anybody ever use this program? This program's free off the internet. It's called Audacity. 15 years ago, this program would have cost you hundreds of dollars. 8 years ago, right? So what are we looking at here?
Sound waves.
Sound waves. What's this about?
How much? What time?
Yeah, that's time, right? So that's second. Oh, remember, yeah, we just talked about decibels, right? Huh. Let's see what happens. Let me choose a nice little chunk of this right here. I'm just going to choose a little chunk of this, and I'm going to hit Control 1. and I am going to magnify this. Well, here, then I'm going to go through to effects, and I'm going to amplify this. What does it mean to amplify? Yeah. What happened to the time up top? Yeah, tiny little decimals, not decibels. You may have to plug your ears. Hang on a second. How much time is that?
A millisecond.
Zoom out again. Oh, okay. Is there some regularity to this pattern?
No. Actually,
Is it a perfect wave?
no.
No,
Nothing.
it's not a perfect wave. Can you see it way back there? No? Too far away, sorry. You can move toward the front. Let's see, how long does it take? Does it repeat? Yeah, does it repeat?
Up and down.
How long does it take it to repeat? Let's see. Does that look like it matches with that one? Let's see. So what would that be? That's 26.6760. That's 26.6770. What's that?
65.
Yeah, 26.6765? Yeah. Let's see. 26.6775. How about this right here? 26.6795 maybe? How much time is that?
That.
Let's see, they match here, they match there, so it's from 75 to 95, 0.0020 of a second. 0.002 of a second. What is sound?
Vibrations in the air.
Sound is vibrations in the air. Is music a sound?
Yes.
Is every sound music?
No. Yes. It can be.
Sometimes what you kids listen to is not music to me. And sometimes what I listen to is not music to you.
Yes.
What things do you know about sound? It travels in a wave. What's a wave? Ooh. What's a wave? Let's see, how's my battery? Oh, that's a very good idea. Don't electrocute yourself.
Did you like?
Okay. Oh. Is that a wave?
Yeah.
Well, wait a second. Are waves going up and down? Okay. Ah, Okay. So, when we're looking at that, we're almost like we're looking at a projection,
Yeah.
right?
Like a hologram.
It's like, this is three-dimensional. If you actually look at this, it's spinning around.
Well, it looks like a double helix.
It's spinning around, right?
Yeah.
Yeah. But if I project this onto the board, it looks two-dimensional. And so we're essentially looking at something which is two-dimensional because we got paper and computer screens and what have you. But we're looking at a two-dimensional representation of a three-dimensional wave. Easy to type up, right? Which maybe you'll know. How can we describe this?
It's awesome.
Let's see. Up, down, up again, down again. Oh,
It's symmetric.
it's like two waves. Why would you say it's like two waves?
Looks like a bunch of,
Let's
it looks
see.
like fish
It
swimming
goes
very
down.
fast up.
Wait, it's
Okay.
like 2 pods.
Oh,
Like that.
you're saying it's like two pods. Let's see. You got this bulgy part, and then this is kind of like not moving. And then there's another bulgy part here, and then it's not moving again. And then there's a bulgy part, and it's kind of not moving there, and then you got this thing down here. So if we want to try to analyze this, why don't we just analyze half of it?
Yeah.
So what are we going to call this, where it kind of goes up and then down, and then it starts repeating again?
Period.
Wavelength? Period. Wasn't that one of the questions
Yes.
on your pretest? What is the period of the Earth's rotation on its axis? 24 hours. The Earth rotates on its axis every... Now, is it perfectly 24 hours?
No.
No. But that's how much time it takes the Earth to start repeating. What is the period of the Earth's rotation around the Sun?
365 days. 7 weeks.
Oh, wait. Actually, 365.249. Isn't 0.25? So, Engelhardt, it takes the Earth 365.25 rotations on its axis to travel all the way around the Earth. So that's why we have leap years.
Yes.
So you take 0.25, 0.25, 0.25, 0.25, so every fourth year, you just tack on another day, and that way things stay...
Is that what's like February 29th?
Yes, exactly. That's why things stay in sync. In sync. Is that annoying? What is harmony?
Different parts of
What is harmony?
Everything goes.
Was the wind chime in harmony with my vibrato?
Yeah.
What does that mean? It sounds good together. Is there some mathematical way of defining sounds good together?
It's ordered. Goes together in the same. It's in the same way.
It's in the same way? Well, then every note would sound the same if it was the same way.
It's the same like.
The way, complementing waves?
It's the same like
I think
time.
It's the same time length?
Going. It could be different pitches, but it's in the same beat,
In the same beat?
like the same time that it takes to go up and down.
You gotta pull plugs down. Interesting. What are the different ways produce sound?
Vibrations.
Oh, here, take a look at this. Yeah, we're going old school, right? You guys are spoiled by electronics. So I'm taking a look at this tuning fork right here. I don't see if you can quite see it. It says A 426.7.
So in the second one,
A, wait a second, what'd you say, Santarelli?
so in a second it vibrates that many times.
So in a second, it vibrates that many times.
Maybe, I don't know.
Oh, I know. I guess.
Martin?
So definitely has a change of mindset. And definitely, I feel like it. Alright. So that obviously is a pitch, right? That number.
A pitch. What's a pitch?
It's like
A tone. A note. What's a note?
a sound.
You're a drama major. Do you sing?
Yeah, I also play piano.
Aha! What do I want from you? I'm just questioning. I'm just questioning. Ooh, Hertz. You mean the car company? No. What's a Hertz?
Sound.
Yeah. Yeah, so now. Oh. Who plays guitar? Who plays guitar? You dabble? Pitch. It's got 440, 441, 442, 443. What's on there? 426.7. This has got 440. How close is 440 to 426.7?
Actually not.
It's like so many cents.
Here, who's got the A tube?
I didn't.
Okay. Where's the A tube? A. Oh! Oh, does anybody have like a tuning program on their iPhone? Yeah. Here, let's try this.
They gotta have that.
Oh?
I do have that.
What?
That's a C, isn't it?
Tube says A, this says A.
Oh, I got the C.
So this tube is A. Let's see. This tube is F. Does that sound the same?
The A was on it.
Let me try that again with the A. So this is A. This is A. That's fa. Do, re, mi, fa, sol, la, ti, do. Do, mi, la, sol, fa, mi, re, do. Do, do. How come? Put the tubes together? Okay. Like this?
That's the best way to
It's just, what makes it sound better with this one, but not with that one?
Oh, I get it, yeah. Because like the sound like is getting to right there and to the all the way down here.
Okay. So, is there a wave going through this tube?
And out of it.
Okay, now how are we going to look at the wave? We're going to look at the wave like this, we're going to look at it like this. Now in reality, it's really like this. But just to simplify things, we'll go like this. And that way we only have to worry about looking at the peaks and kind of the stationary points. What are the different ways to produce sound? Skylar, make sure you got one. Let's take a look at one more video.
Yeah!
Yay! Let's call them thought sheets. Right? Finish passing these up.
You say thought sheets? I heard thought sheets. You heard thought sheets? I didn't know what kind of thoughts. Like thoughts. My boss, because I'm unemployed. I don't know, you said you know. What's her name? Oh, yeah, yeah, I see it.
Oh, yeah.
I gave you one, Sean.
There we go.
They're black. They're black, they're dirty.
Let's do a classic physics experiment called the Rubens tube. Now, I really want to bring it down, but it involves open flames, and some people have issues with open flames. So, what we have here is a ring of PVC pipe, has about 100 or so holes drilled in half-inch increments, because the foil tape keeps from melting. On this side, we've got a 2-inch speaker matching the diameter of this 2-inch tube. On that side, we've got some lab tubing leading to some propane. So let's fire it up and see what it does.
Fire it up and see.
Alright, as you can see, we got some nice standing plates, a little bit of oscillation from the vibrations in the hose. Let's throw some sound in there, see what happens. Let's start with a 449 hertz frequency. As you can see, this sets up a standing wave, and we can see, well, the emerging sine curve that represents sound. What happens here is you're having the sound compressing here and not compressing here. The lower pressure here allows more gas to escape into the atmosphere, shaping the sound curve. Now, if we change the frequency, we can see each time we set up a standing wave, we get that sine curve. Higher the frequency, the more waves. Now let's throw some music at this. Pull some Dave Brubeck. Now we have real life sound visualization with fire. Now Dave Brubeck isn't terribly energetic, so let's try something a little more energetic.
Work on that handout.